Hello everyone. In this video, we're going to be solving a nice rational equation. We have 4x squared plus 10 divided by 3x equals 61 over 9, and we're going to be solving for x values. I'll be presenting two methods, even though one of the methods may turn out to be incomplete. All right, let's get started. For my first method, I want to go ahead and make a common denominator, or you might just as well multiply everything by 3x. That would give you 12x cubed plus 10 equals 61 over 9 times 3x, which you can write as 183 over 9x. And then you can go ahead and put everything on the same side. 12x cubed minus 183 over 9x plus 10 equals 0. Now, if you want to solve this cubic, there's a couple different ways to go about it. One of the methods is you can use the rational root theorem, if there are any rational roots, of course, right? If there aren't, then that method is not going to work. But at least you know that either you'll find rational roots or you'll know that there are no rational roots. So you can try something else. Maybe factor by grouping. Maybe you can split up one of the terms to make something favorable. But anyway, let's go ahead and think about the rational root theorem, which is usually abbreviated as RRT. So this is how it works. You look at the constant term and consider factors of the constant term. So in this case, that will be plus minus 1, plus minus 2, plus minus 5, and plus minus 10. And then you look at the leading coefficient, which is the coefficient of the term with the highest power of x. In this case, that happens to be 12. And you look at the factors of 12, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus minus 12. There's quite a few options. As you can see here, there are 12 options. So 12 has 12 divisors, which is kind of interesting, I think, right? If I didn't make a mistake. Great. So how do I put these two together? Well, you take one of the factors of the constant term, let's say 5, and then you take one of the factors of the leading coefficient, let's say 12, and then make a fraction. And plus minus, of course, all options can be used. And that's going to give you a lot of choices. There's a lot of candidates which you have to go through. That's why this is not a good method. Obviously, a computer program, a code, script, whatever, or a calculator will be able to go through this real quickly. So 5 out of 12, you plug it in, can x be that? And you'll soon realize that doesn't work. So that's not a solution. And then you go to the next one. Systematically, you pretty much go over them. And sometimes you may get the same thing. For example, 2 over 6 and 1 over 3 will give you the same thing, so you don't need to check that twice. Make sense? So you kind of eliminate the duplicates. Anyways, this is a long process, but if there's any rational roots, that's guaranteed. There's another way to approach it. You can also multiply by, let me see. You probably need at least an 8 or a multiple of 8. So you may want to multiply everything by, is it 2/3? Yep. You multiply everything by 2/3 and then try to replace 2x with something like y and hopefully get a mnemonic from there. I don't think it's going to be a good one. But anyways, you can try couple different things. Or worst case scenario, you can use the cubic formula. How does that work? Here's how it works. Let me quickly show you. You kind of leave the constant term on the other side of the equation. Since it's already depressed, you can go ahead and, which means we don't have x squared, you can go ahead and consider the identity. But in order for that to work nicely, we want this to be a mnemonic. So let's go ahead and multiply everything by 1 over 12. And that would give you x cubed minus. And if you multiply this by 1 over 12, that'll give you 183 over 109. I don't think that simplifies because 183 is not divisible. I think it's prime, most probably, right? And we'll multiply by 1 over 12. That's going to be negative 5 over 6. Great. Now, at this point, you can just go ahead and consider the identity a plus b quantity cubed minus 3ab times a plus b equals a cubed plus b cubed. That's how I remember the cubic formula. Obviously, I don't memorize the formula. I just know the method. And now if you call this x, you're going to realize that a plus b is a solution of this equation, obviously, right? Because x is a solution and x is a solution of this equation. So if x is a plus b, then a plus b is a solution of this equation. Therefore, by comparing the coefficients, you're gonna get the values of a, b, and a cubed plus b cubed, which allows you to set up a quadratic system of equations after going through some stuff, which is time consuming, but it's worth it. It's gonna be really good practice. So cubic formula is not as straightforward, but you can also memorize it if you want, okay? Especially for depressed cubic, I think there is a formula like for something like this. I can't remember exactly, but something like there's a 4 over 27 something in the equation. I didn't even memorize it, but you can just look it up. Anyways, quartic formula, don't look it up because it's scary. All right, I'm pretty sure you will. But anyways, so you can definitely solve. And can we try rational roots? Yeah, in this case, it's going to be a little easier. And I think this will be a great advantage because if you consider this, the only thing you need to look at is factors of 5 over 6. But how do you handle 5 over 6? That's a good question, right? So that would be a little tricky, but if you think about it, I'm pretty sure you'll find it real quickly. So let's go ahead and take a look at the second method, because I think the second method is much, much better. All right. And since this is a competition type of problem, like something that might appear on math competitions, some of them even called Olympiads at the middle or high school level. Maybe this could be like an 8th grade or 9th grade question. This method, you need to be familiar with this. And these problems are especially designed for these kinds of things so that they allow special methods, okay? That's why you can go with the alternatives. Okay, so here's what we're gonna do, and this is not always easy to see, but here's my thinking. I want to go ahead and, actually, did I write 4x cubed? I think there should be a 4x squared. Okay, never mind. I'm like, looking at this like this doesn't make sense at all. Okay, here we go. So 4x squared. So here's what I'm looking at. I'm seeing this one right here. That's a perfect square. So if I can produce another perfect square on the right-hand side, I can bring it over, make it a difference of 2 squares, and then I can put that thing maybe on the right-hand side and kind of make both sides factorable so that they have a common factor. You get the idea? That kind of sounds confusing, but here's how it goes. First of all, we're going to split up 61 over 9 into 2 pieces. And guess what? We want at least one of them to be a perfect square. And this is how it can be done. Think about it. 61 over 9. If you divide 6 into 9 into 61, I mean the other way around, it's going to go 6 times, and you'll have a remainder of 7. So you can write 61 over 9 as 6 plus 7 over 9. And 6 is not a perfect square, so that's not very good. And 7 over 9 is not a perfect square either. So I'm going to try something else. Maybe pull out a 5 and then add 1 to this, so that's going to be 16 over 9. This is somewhat promising because 16 over 9 is a perfect square. So I can try this, okay? Again, I'm showing you something that may or may not work because you don't always get to the result, right? I mean, sometimes you have to try different things. So you can see the process. Okay, I can bring it over here like 4x squared minus 16 over 9 and then bring the 10 over 3x here. And now at this point, I can try the following. This is like 2x plus 4/3 and 2x minus 4/3. Am I going to be able to get something like that on the right-hand side, like 2x plus or minus 2/3, which minus makes more sense, obviously, because we have a minus sign. But in order to be able to get that, I kind of need to multiply this by 5 over 2x, which may or may not be a good thing. You can definitely try, because I have another idea. This will probably work. Let me check this real quick. If I write this as 5 over 2x, am I getting what I need? Yep. Am I? Yeah, I'm getting it. Okay. This works. Okay, cool. So the 2's cancel out and I end up with 5 and x cancels out 2. Okay, so this will work. But this is not the only way to split it up. So that's why I want to show you both. If you reduce this one more time, this will give you 25 over 9, which is really nice because they're both perfect squares. So it can't get any better, right? So I'm going to go ahead and bring down the 25 over 9 here and leave the 4 with the, what's it called? This one here, 10 over 3x. And at this point, you can do 2x plus 5 over 3 and 2x minus 5 over 3. And here, if you want to get this, you will just need to factor out 2 over x, and it'll be the same thing. Which method is better? I can't really decide, but this was my intention. That's actually how I came up with this problem. Looking at another problem, by the way, so I stole the idea. Anyways, people do that all the time, right? And now we can bring these together, okay? Since this was my initial thought, the other one just came up. I'm going to go ahead and bring these together and factor out 2x minus 5/3. I have 2x plus 5/3 coming from here. And from here, I'm going to have a minus 2 over x, right? And then now when you distribute, you're going to get the exact same thing. And if you set this equal to 0, you're good to go because you'll get a linear and a quadratic from here. Nice. So from here, 2x minus 5/3 or 2x equals 5/3, which gives you x equals 5 over 6. Uh-oh. Does that really work? Going back to the cubic that we had, if I look at factors of 5 over 6, one of them is 5 over 6, so that would work. But again, I mean, testing will take a while. It's not the best method. So what about the second one? For this one, I can go ahead and multiply everything by, let me set it equal to 0 first. And then multiply everything by x, maybe 3x. How about that? 3x is better. 6x squared plus 5x minus 6 equals 0. You probably know this is factorable, but let's use the quadratic formula. Negative b plus minus the square root of b squared minus plus 144. That's going to give you 169, which is 13. Negative 5 plus minus 13 over 2. If you split it up, negative 5 plus 13, 8 divided by 2 is 4. So it's going to give you x equals 4 or x equals negative 9. So yes, we have 3 rational solutions. It's a nice cubic. And as you can see, you could also guess probably 4 or negative 1. Who knows which one you're going to be estimating or guesstimating. Okay? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.